Alright guys, welcome to another electronics video. This is going to be a short one to tell you how to find a short circuit on a motherboard and where is it related to. So the one we're working on today is this HP all-in-one PC, and the model number of this reads 310-1025A. And this one I've already disassembled, and if you are working on this, to disassemble this is quite tricky, so do watch a video on how to disassemble this so you're not breaking the panel on the side of it, as it is rather tricky. So I have gone ahead and removed the motherboard out of this unit, and there it is there, as well as the fan that I usually take out anyway. So let's plug a few things in, and let's see what the problem is. So defined and described by the customer that this does not turn on and the light keeps blinking. So this light here keeps blinking, and so let's confirm that. So there's the power jack. Let me set my power supply to 19 volts. Let's grab the input lead, and they say as soon as you plug the power in, this just blinks. So this is the power input cable that goes on the side of the machine. So let's plug this in and let's see what happens. So alright, so we get 3 blinks on here, and the power supply is drawing 0.030 amps. Okay, so let's press this. So we do have a light on the board. Let's press this and see what happens. Okay, nothing. So I will disconnect this now, and then I will plug my fan in and see what happens then. Okay, and then see if this actually turns on or what's actually happening. So they say only this light keeps blinking, there's no sign of life. So let's press that again. Nothing, no fan spin, no nothing, no signs of life on the board. Okay, that's alright. So let's disconnect this, remove the fan, and press the button a few times to draw any residual currents that's on the board, and move on to doing some power checks. So power adapters go in here, and let's flip that over and let's turn it to our side to have a better view. So what I'm looking for again is, if you're starting to learn this type of repairs and you're wanting to upskill yourself a little bit, the first thing you must do, and the way that I do things, is just visually look. Just visually look at the board and see if anything looks out of place, anything looks burnt, or anything looks damaged, or you feel that it doesn't look right the way it's supposed to. Just use your senses. That's the way you start off with. It doesn't cost you anything. It belongs to you, and you can use it whenever you need to. So just thoroughly have a look at the board, visually inspect it, and see if anything is standing out to being damaged or blown or out of place, and that could save you time in repair. So if you know there's like this capacitor is blown, then you know your problem will be surrounding that area most of the time. Other times it can be tricky. So right now there's nothing that really stands out of what's maybe causing this fault. I don't need to check my 3.3 volts here, because I do know that it is present, only because the light is on, and also when you press the button you get some sort of a signal coming out of it. But just because of the heck of it, let's do that. Let's check if we are actually getting 3.3 there. So we've got that over there. Let's bring our multimeter in frame and set it to DC volts, and find any of these brown ground pads, and let's probe onto the first pin and let's see what we get. So that one must be ground. So we got 3.3 there, we got 3.3 on that one, have 3.3, and we have, must be a ground one there as well. Okay, so we can confirm we have our 3.3 volts available on the motherboard, yet it's still not turning on. Okay, let's investigate further. So we've visually looked and we can't see anything that's burnt or out of place or missing or things like that. So now what I'm looking at is I'm looking at the power jack where the DC jack goes in. I'm looking for anything around there that has a fuse, that has a MOSFET, or anything that's leading from that power adapter. So this power adapter is a little bit different. So if you are working on this, do start off by checking your power adapter and checking that you are getting volts coming in. And if you look at this power adapter, you'll notice that you'll initially think that, I'll see if I can point this out to you, but you'll notice that you've got an outside bit here, you've got an internal pin there, but have a look on the side. So that inside metal bit there, so let me grab a plastic spudger so I can actually show you. Okay, so you notice, let's see if I can bring that, so this bit here, okay, that's your positive. Okay, so that's your negative, that's your positive. The center pin is your sense line. So a board needs to have this to say, hey, look, I've got the charger input now. All right, so that's your sense pin, and this is your 19 volts inside it, and you've got your ground here. So let's confirm that. Bring your multimeter in. To start off by checking the basics, and then we can move on to doing the rest of it. So I'll show you what I mean. So I was confused by this as well. So here we go. So that's our ground. Okay. So we've got a ground. And if I touch on the center pin here without blocking your view, so that's the center pin. Okay. So that's your center pin there. Okay. Need to just do this. And if I touch the center pin, okay, we get 19 or 18. Okay, so that's the center pin. Now that's the sense line. Now if I go into the side body of this, you should get 19 volts. Okay, you see what I mean? So on the center, we get 18, and on the side, we get 19. Okay, so that's how you confirm that this works. And obviously it'll work like that, but if it's under load, it's a different story. So let's bring the board back into focus. And we know the power goes into here, so we will plug our power supply into here, and we get 0.030 amp draw. And now I'm confirming where is this power going on this board. All right, so the jack is here, and it corresponds on the other side to this place here. Okay, so it comes out and it goes to this place here. Okay, and we will probe. Wondering how I can get all of this in frame. See if I maybe move this up, move this across. Yeah, there we go. We're going to be working in this area anyway. So there we go. And I am now just randomly probing around on DC volts mode, and I am looking for my 19 volts. So we know the power adapter is here, the DC in comes into here, so I will probe onto this pin, and that's ground, this one's ground, and this one here is our 19, so it's our 19 volt. And this is our sense line. Okay, let's clean this. Let's touch on this one. Okay. Sometimes they have a coating on the board, so yep, that's our sense line. And now I am following where my 19 volt goes. Okay, so you've got 19 coming into here, this port here. Alright, it goes through here, goes through this inductor, goes through this FET here. So I believe this is a step down, so we should have 19 here. We should have 19 on this side. We have 19 on this side as well as on this side. And you notice how it splits off. So this side here is 19, and this will give us a reduction. Yep, 9 volts. And on this side should be 19. So this obviously feeds off to some other line. And we got 19 coming into here, all the way down here. Okay, and then another inductors here. And then there's our FETs. So we have our FETs here. And then now we want to check is the voltage up to our FETs. So let's probe on this side, and it is. Yep, so we get the voltage present on that side, and now we check on the other side of the MOSFET. So on the other side, let's have a look at our ground. Okay, so we don't have any voltage on this side of the FET. Okay, that's a bit strange. So, okay, great. So we know we have voltages up to this point here. So we have our 19 volt up to here. We have a 9 volt up to here. And then we have nothing on this side, correct? So why is that? So sometimes these chips are quite intelligent as they check for anything past that circuit, if it's damaged or shorted or anything like that, and they shut off. They shut themselves down. If the cheaper chips that are have a weaker thermal resistance or thermal conductivity, then they will just break, and over time, because of the material they're made out of is flexing, and they'll just break and burn out. So we know voltage comes up to this point here, okay, but nothing past this point. Okay, so what I want to do now is I want to remove my DC in. Let's put that there. And I want to now check, so I'll press this button to remove the current discharge. I now want to check if I have a short on this side of the motherboard. Okay, so the only reason I'm saying that is if you know you've got voltage up to here and then you replace this chip, but you haven't confirmed that you don't have a short past this point, so that's broken because of a specific reason, right? One of them could be that it's a weak chip or it's the manufacturing fault. But the other reason is that's blown or that's not working as it's supposed to, is because something past this section here is what's faulty, right? So always check. That will save you a lot of time in the long run, and always check, as it's also a learning point for yourself, and it confirms that yes, your diagnosis was great. So what I will do now is I'll change my multimeter to diode scale. Okay, and then I will bring my red probe on ground. So again, any of these points here is ground. So if I touch here, or if I touch here, that's ground. So we know we get 19 volt up to here. So I will check this point here. I should get a diode reading, which I do. And I will check on this side of the MOSFET to check if there is any shorts. So let's probe here, and we do. Look at that. So we have a short on this side of the MOSFET. So now that confirms that the chip has blown because there's a short on this side of the board. And now we can go ahead and check what's actually going on. So what are the things that are on this line? So we have 2 other MOSFETs here, and then we have a resistor, we have a capacitor, and then we have these vias on this big pad that leads up. So what's near this area? So we will now bring in our power supply, which is set to 5 volts. So let's do that. Okay, I just use 5 volts, which is at a lower voltage and a current of 1.5 amps. And again, I've got my leads here, and I can just use any one of these ground planes. I can just use this one or this one here. Yep. And then I've got my so if I touch on here and I touch on here, I should get 5 volts reading. Okay, we have 5 volts on that. Okay, so now let's probe on this side of the motherboard. So you'll hear my power supply whine, so unfortunately I can't show you, but you'll hear it. So if there's a short, you will hear it. Okay, so now the power supply has dropped down to 0.94 volts at 1.5 amps. So we know there's a short on this side of the motherboard. So what are the things that are on this side? We've got that resistor, we've got this capacitor. And the way we can determine that is a little bit of IPA. So if you spray a little bit of IPA on this area, and this time let's turn the light on and see if you can see that cap. So let's inject voltage on this side. Okay, we can see and just feel our way around. Ouch. Okay, so that cap is getting quite warm quite fast. So that was quite lucky, we found it straight away. Yeah, so that cap is getting quite hot quite fast. Okay, and now what I will do is I will remove that cap out of that circuit, because I want to know what is actually causing that short, right? So let's try this area, and I will remove that capacitor out of that circuit. And sometimes chasing faults can be a little bit difficult, because you can go down a rabbit hole quite rapidly, and so you just have to know when to stop. And let's do this. So we will hold just the top of the cap, and let's remove that side. So one side of it is fine, you can just remove that. Okay, so we've removed that, and now let's inject voltage and let's see. So what I've done is I've just lifted it on one side, just like that, so it's not making a contact on the board. And let's bring our power supply in, set at 5 volts, 1.5 amps, and inject voltage once again on this side. Okay, so now we're drawing 01.07 at 1.5 amps. So we know it's not the cap, so let's replace the cap back in circuit. So we know it's not this, or we can leave it out. You'll leave it out, eh? We'll leave it out. And what else do we have? We also have a resistor. And let's bring our multimeter back in circuit. Red probe on ground, and let's check if the short is still there, which it is. So the short is still present. The other thing you could do is you could check resistance to ground. So red probe on ground and check for resistance, and that's almost a direct short. You can see that. So taking into consideration your multimeter leads, my one reads 0.2, 0.3 ohms resistance. That's my leads, and so that from there is a direct short. Okay, so we have a direct short on that line. Now what I do is I've got that resistor there. We'll take some measurements. So we have 1R0, so that dot, sorry, the R stands for a dot, so 1.0 ohm resistor. So let's probe here and here, and that should be 1 ohm, a resistor, but it's not, it's reading short. Okay, and now what I will do is I will then remove the resistor out of circuit, and let's see if that actually fixes our problem, or if that is what's causing our problem. So how will we do this is we will grab some tweezers. Let's move you guys in a little and zoom in slightly so you can see, and get rid of this, don't need this right now, and apply a bit of solder on this side. Okay, and you can just slide in a okay, that's it, it's not making connection anymore. And I want to remove, I completely want to remove this cap out, this resistor out of circuit. Let's do that. Great, so that's out. There's a little bit of epoxy underneath it, so just be careful of that. Once you remove something out of circuit and it's hot, just let it cool down for a little bit, because if you start taking measurements straight away, you will, that's quite warm, the measurements will not be accurate, and because obviously heat increases the resistance of that. And now I will check this. So let me spray a bit of IPA onto this to cool it down, and I'll show you on resistance mode. This should be reading 1 ohm or close by, and okay, and that's reading 0.5, 0.4, so that will need to be replaced. So that's not really reading the best. But if I swap my leads, does that make a difference? If I put it on here, yeah, so that's a shorted resistor. Okay, now we'll bring the motherboard back into focus, and this resistor sat here. We've removed that out of circuit, and just for the heck of it, let's remove this capacitor out of circuit as well, so we have a bit more room to see what's going on. And yep, that's out. That cap's out. Okay, now I will probe this point and check if the short is still there. So we know there's capacitor and the resistor is out of circuit, and there was a short there. And now again, diode mode, red probe on ground, and this side. So look at that, on this side we don't have a short anymore. So remember, we had 19 volts coming into here, and on this side we had a short. We don't have a short on this side anymore. And let's probe on this side, and on this side the short is still present. So we will probe on this side, and there's a direct short there. Let's change to ohms and probe ground, and this side of the FET there's no short present, and on this side of the this is where the resistor set, the 1 ohm resistor, and it's a direct short. So we still have a direct short on this side, which is, again, you're chasing this fault, and you're going, where is it going, man? How do I know where it is? So now what you do, it's set at 5 volts, and you inject voltage on this side. Okay, you can hear the power supply, and you can again slowly and carefully probe your touch the board while probing those points, and just feel your way around and flip the board over. And what I may do is make it easier is, again, I've got my alligator clip with a wire on the end. Let's grab my soldering iron and let me solder onto this junction here, and that will just make it easier for me while I'm flipping the board and stuff, injecting voltage. Just makes that much a little bit easier, so I'm not having to, because this is on this side and I can clip it to a power supply if I need it. Flip the board around, grab these points over here, and I will connect this power supply to here, and I'll work my way around the board, just feeling the board, seeing if anything's heating up. Okay, so nothing. I can't see anything or feel anything on this side that's heating up. Disconnect the amps. Don't want to be burning the board out or anything like that. Okay, so I cannot feel anything that's heating up. And you must be like, what's going on? What's going on? Why is there still a short and I can't feel what's going on? So here's what it is. So remember, if you've watched a couple of my videos, I've also always mentioned that disconnect all your peripherals that are connected to the motherboard. So that comes in the form of any other connectors or RAMs or Wi-Fi chips or stuff like that. Disconnect all of them, because if your fault is, if you're checking like this and you disconnect the Wi-Fi card and your fault is gone, you know your fault is associated with the Wi-Fi card. you don't have to look further. So if you've got everything connected to the motherboard and you're still trying to chase faults, you will spend a lot of time and devote a lot of time to finding that fault, and it could just be on one of these other cards, right? So what I will do now is I am going to remove this Wi-Fi card here, and whilst doing this I will inject voltage again and see where if the problem is there or if it's gone. And always disconnect everything that's on the board before you're trying to troubleshoot and stuff like that. So we go there and we connect our power supply, but the fault is still persistent, so the fault is still there. Now what I'm going to do is I will remove this, so this whole heat sink, as well as if the CPU is able, it looks like the CPU can come off, so we will remove the CPU along with the heat sink, only because I just want to be absolutely sure that the fault is not embedded within the CPU and the fault is somewhere on a component on the motherboard. So if you start logically thinking about where could this fault reach to and where could it be, then you'll cut your time of diagnostics in half. And I've done this previously as well whilst I was learning, and I'm still learning. So let's remove that, and let's remove the CPU out of the way as well. So it does look like it comes off. Okay, so it does come off. How does this? Okay, let's lift the CPU out. That's the CPU number. And okay, so we've got all of that out. We know that, so that's just to confirm that the CPU is out and this fault is not in the CPU, and if we're injecting voltage we're not damaging the CPU. And because this is relatively close to where are we? So this is relatively close to where the CPU sits. I am having a feeling that this actually might be linked to something around the CPU or directly to the CPU. So let's inject voltage again and let's check our suspicion. And here we are. So we've got the CPU out, we've got the power probe, the power supply probe and the probe from the motherboard, and let's connect it up at 5 volts and 1.5 amps. And look at that, we don't have a short anymore. So the power supply is sitting at 5 volts, 0.049 amps. So it looks like we may have a faulty CPU. Let's bring the CPU back into picture. How does this go? Let me... So this sits like that. Right. Let's close that and inject voltage. Okay, so the power supply has gone to 0.93 volts at 1.5 amps. So it's taking the full 1.5 amps. Interesting. Let's remove the CPU. I suspect the CPU is blown. Okay, inject voltage. Nothing. So it's at 5 volts, 0.049. Wow, okay. So we have traced our fault down to being a faulty CPU. And that's this one here. So we will get another one. And so we were told to just inspect this board and find why is it not turning on and what's actually going on with this. I will now, what I can do now is I'll reapproximate all of the components back onto the motherboard, and just so I know where they all are, and tell the customer that this is a CPU related fault, and we can try and find you another CPU and see if the system will boot up, and we can go from there. So that was just a little video to show you guys how to trace the fault, and if it is leading to the CPU or any of the surrounding chips, you can logically work your way around. If the power is going into the board, and where it comes out, does it go through a few components? Does it go through a voltage regulator? Does it go through MOSFETs? Is there a fuse on the line? Where does it go after that? So there's always ways that you can logically think about it. Have patience, and learning is a process, and you can do this. Just have to have that little bit of patience, and you will learn how to do all of this. And with that being said, alright guys, so that comes to the end of this video. I hope this video has helped somebody out there, and thank you for watching. Okay, just before we finish up, I do want to confirm and show you that the short is actually gone. The CPU is out. Red probe on ground again. Let's bring this into frame. So that's just there. Red probe on ground, and let's probe on this side. And we have a good diode reading there. And our short's gone. And let's go to ohms. Okay, we get a high ohms reading, which is good. And on this side, we also get a good reading. So once we get a new CPU in, we do need to replace this chip to allow for voltage to go further past that point. Okay, so that's it. Thank you for watching, and hope you learned something from this video.